And then there were 3 of the 3 ways with 2 switches. Or is it 3? Or isn't that a 4-way? Confused as I am, let's check out this smarter 3-way switch and why it impressed me so much. So if you've seen the Martin Jerry switches before, you're going to be very familiar with the look and feel of this exact switch. Comes with the standard Decora faceplate. That is a screwless design, and it does pop off very easily. They do give you the wire nuts like before. Take those off. We will be using the Wago 221 connectors, because once you go to the Wago connectors, you just really can't go back to using the old school wire nuts. So one big difference, of course, in this switch is you do get the additional traveler wires. So pull this off here. Yeah, we know it's an electrical shock hazard. Of course, yes, make sure and do turn off your breakers and double check, triple check, don't forget. And you should be also checking your switches and wiring with a non-contact voltage tester before you touch on them, because you never know what is live in a box and not. So this is the model ST01. Here's the FCC ID. It is rated for 100 to 240 volts. I know people always ask if it does work up to 240 volts. And yes, this one shows that, and 50 to 60 hertz. The max output, or max it would actually use, is 1800 watts. And of course it is 2.4 gigahertz because it does have the ESP8266 inside. Now you do get the 2 travelers, since this is for a 3-way. You get your live, which is basically kind of be your input, neutral, and your ground. So same little Martin Jerry switch we're used to. It does fit in a standard Decora plate. So if you do want to use this in a 2 or 3 gang setup that you already have, multiple switches, this does actually fit just fine in a Decora switch plate that you already have. The holes do line up in the top, and you can screw it in and it will match your other switches. So real simple for that. Let's pop into the switch and check it out. So be sure and check out the video description down below. We will leave links to various tools, which does help things out, as well as we'll leave updates if needed to things based on this switch. So usually if you come down the side with the spudger on the corner, you can pop the little clips to open the switch up. You should see the 2 clips, and then it should rock right out of it. And the ground sometimes will be holding you in. If you do take the ground wire and push it into the hole, it will force the faceplate right out of the switch, because the ground is just a pass-through again on this switch, where it goes to this plate that will ground, say, the box, or if you're using a metal faceplate. So I would recommend hooking the ground up even if you're not using it. You never know when someone will change out the faceplate to a metal faceplate. So we'll pull this on through, and luckily they do give us a plug again, and we'll just unplug the faceplate from the base of the switch. So there's our 16 amp 250 volt relay, and then where it's at, the faceplate. You can already see the back of our standard 2U module that we're used to. So there are 4 little Phillips screws that we'll need to take out of this, because as of the recording of this video, this faceplate does come 2U patched, and you won't be able to use it with 2U convert. So of course we will need to solder only 3 wires, because we will use the hot and ground provided in this plug here. And take note, don't always trust the labels on boards nor the colors used, because I have found in some cases that the ground is not correct and the 3.3 volt is not correct. So we will be checking that out to see if this one is backward or not. So definitely don't trust any labeling on any switch, no matter who it is. So I always thought this was interesting. They always still use the same faceplate as the dimmer that has the spots for the 5 LEDs, even though this is just a switch. So here's the faceplate. Of course, the same little 2U module we're familiar with. You do get the same little reset button that they've used before, which is actually just basically a reboot button because it hooks straight to the reset pin on the ESP chip. You'll get the dual color LED, and we will be able to control the colors independently, whether we want blue or red at on or off. You get your button. So here's one thing I wanted to show you. You'll notice there's 3.3 volts here and ground listed here. When you flip the board this way, there's ground on the right, 3.3 volts on the left. Now back over here, there's 3.3 volts on the right, ground on the left. That's which one is correct, this side or this side? Well, just from me knowing the pinouts of this 2U module, you can actually see the trace for ground to this ground via hole actually attaches to the ground pin on the ESP. The 3.3 volt pin is right here at the bottom. So this side is correct. This side is incorrect, including the colors. So on the back of here, and if yours is the same as this one, remember that the 3.3 volts is black and the ground is red. So definitely check your switch. They may fix this in a later revision, but if not, double check it and keep in mind that it could be incorrect. So an easy way to check is take your meter and put your lead on the hot on the red side, and then figure out if it's connected to this pin or this pin. If the 3.3 volt red is connected to this pin, great, and they did fix it in your revision. If not, just keep in mind it could be backwards. So we'll have to solder to the RX and TX pins up top, as well as the GPIO 0 pin. And we will leave the link to show the exact pinouts on what to solder to. Now, if you really get creative, and I have seen some people do that, they actually have held some jumper wires to these pins using like some blue tack or some tape and attach them to their USB flasher. You can do that, just be careful of doing that. Don't let your pins touch the ground of the case here. They're not too bad to solder to, so let's go ahead and get that soldered up. So basically what I like to do is I like to take some simple DuPont jumper wires, and you can just cut the ends off of them and strip a little short piece off of it, and we'll apply some solder paste to the little end and we'll pre-tin them. And then you'll also do the same to the switch. And it makes it super simple even for a very beginner to solder a switch. So don't be scared if you haven't soldered before. We've shown this method before on the Sonoff S01, and I've had various people from even their very first soldering method that they soldered even the S31 that doesn't have through via holes. So I did cut these a little long, but that's okay. You can just go ahead and tin them, and then you can trim them afterwards. So go ahead and tin the entire piece, and we'll do all 3 of them. Again, we only need 3 of them because we will be using the plug to do 3.3 volts and ground. That's it, and then we'll pre-tin the points on the ESP chip. We'll see if we can get a little bit of solder to stick to the RX and TX pads. And now that you've tinned both sides, the wire and the pad, you can simply put the wire up to it and just heat the 2 together, and they will pull together since they both have solder on them. This is a little more difficult to solder by camera, but we'll see what we can get it done. There's GPIO 0. We'll do the RX and TX lines. There's one of them. And we'll do the last one. And that's all there is to it. And again, we'll use the plug for 3.3 volts and the ground. So we'll go ahead and attach the wires to our USB flasher. And do remember that the plug is backwards on my particular model. So ground on the plug is actually 3.3 volts. So we'll go ahead and get that one out the way. And then The hot wire is actually ground, and we're using our standard little header pin that we bridge for the 3 wires to get GPIO 0 and ground together. You can use a breadboard like we've used before if you want to connect those, if you don't want to solder a header pin together. Whatever method you want to use is fine as long as you can connect ground, GPIO 0, and ground on the USB flasher and ground to the chip. GPIO 0, TX pin is red on the ESP chip, which that goes to RX on the flasher, because RX goes to TX and TX goes to RX. And then we'll connect our yellow to TX on the flasher. And we'll double check everything, make sure your solder leads did not come off, and then we'll apply it to USB power and we'll go ahead and flash it. So once you get the 3 wires soldered up and you do have the ground and the hot male jumper wires pushed into the plugs, since you don't have to solder those, we'll need to go ahead and download the firmware from Tasmota. If you're familiar with all of this, you can skip straight through, but we're going to show it for the others that don't know how to do it. We'll leave all the links to the GitHub pages to download all this software. So if you head on over to the Tasmota GitHub page and go to releases, as of the recording, we're at 6.6.0. If you scroll all the way down, we are looking for the Sonoff bin. There it is, third to last one. We'll click and download the Sonoff bin file. And then we'll go get the Node MCU Pi Flasher. If you click on releases, and we'll get the 64-bit version since we are using Windows 10 here with 64-bit. We'll download that one. And also an easy way to configure it is to download Termite. And you can either download the complete setup or just the program only, and you'll just need to run it as a simple terminal program so you can configure your Wi-Fi SSID and password on it with ease, or you could use the access point manager, whichever way you choose. So what I like to do is go ahead and open up Node MCU Pi Flasher, and I'll take a look at the COM ports that I have, and mine has 11 and 12, probably due to Bluetooth or something else. Then I will plug in the USB and hit the refresh to see which new one comes, and that way I know exactly which COM port my USB flasher is. So I plugged it in, we'll go ahead and hit the refresh button, and now you can see I have a COM 16, so I know that's the one going to be for my USB flasher. We'll browse to the Sonoff bin file. We'll go ahead and leave it at 115/200 for the baud rate. It'll change it to D out. And we'll also say, yes, wipe all the data. And then we'll hit flash. And you know you have it when you start to see the detecting chip, and it shows the MAC ID, etc. And we'll let that flash on through. Now someone did ask previously that some of the new Tuya modules we've been seeing are coming with a 2 meg flash size. Can we still use the normal Sonoff bin file? Well, yes, you can. It's just like when we flash, say, a Wemos D1 Mini that has a 4 megabyte flash, and we'll flash a 1 megabyte file. As long as the flash size is larger than the bin file build we're putting on it, then you're good to go. I figure they're probably including more flash size to include something more with encryption for probably some later Tuya convert cat and mouse games possibly. And that's just my opinion. So once it's flashed, we'll need to remove that GPIO 0 from connected to ground, and then we'll plug it back in. Otherwise, if you just cycled the power through USB, it would come back into bootloader mode and Tasmota wouldn't be booted up. So go ahead and unplug it, and then the GPIO 0 is this cable here. We'll just let that hang, and then we'll plug it back in. Remember, it will be COM 16. So we'll close Node MCU Pi Flasher, and we'll load up Termite. We'll need to change the COM port to COM 16, and we'll leave it that same baud rate for 115/200. Hit OK, and we should be able to click Enter at the bottom, and as soon as you see that command unknown, then you know you have Tasmota running. Now at this point, we need to put in our Wi-Fi SSID and password. What I like to use is a backlog command, and it's just put backlog space SSID and then the SSID. Then you put your semicolon, password 1, then the password, hit enter. And that'll populate both of those at one time. So in case you do miss it, if it reboots, you don't see the IP address, you want to see the connection, you want to see that WIF connected, and then you'll notice that we'll give you the IP address that you can use to configure the Tasmota switch in the GUI of Tasmota itself instead of using the command line here. If you're familiar with doing the commands, go ahead and finish it out, but we're going to jump over to the Tasmota GUI. So once you get into the Tasmota GUI, the first thing you should probably do is go configure your MQTT. That way you'll get it connected to your broker and it will stop some of the delays as well. So go to configuration, configure MQTT, put in your host information, leave the port the same, the client, and now you'll need to configure the username and the password. And then for your topic, you will need to put a custom topic that is unique to each device. So we're just going to call ours MJ3way1, and then I'll fill out my host and username and password. One way to check is you should go to the console once it does reboot. Look for this message here. It'll say MQT:*connected. And that way you know you put in the correct MQTT information. If not, doesn't show, it shows a failure, definitely go back and go see what's going on, whether you mistyped something or something like that. So the last thing we're going to do is we're going to throw in the template, and I will leave the template in the video description, and it's going to configure all the pins for you. And the real cool part about this switch, there's no rules to do the three-way switch, unlike the eTech City and the Mo's three-way. The switch handles that all by itself, which we will show. What you'll do is go to configuration, configure other, and copy and paste the template we gave over that one, hit activate. And while we're here, we'll go ahead and put a friendly name. I like to usually make it match the same as my MQTT topic, but you don't have to. Hit save. Now at this point, we'll go ahead and unsolder those 3 wires. We'll go ahead and put it back in this switch, and we'll connect it to a light bulb. So once you do put it back together, and if you do go ahead and wire it up in your home, make sure and do put a light bulb load on it or fan or whatever you're going to use with it. Now keep in mind with these three-way switches, with the way they work, they will have a little bit of voltage that can be in the light bulb socket, but you probably shouldn't be sticking your finger in the light bulb socket anyway, whether the light's on or off or whatever. So always go turn the breaker off. The way we have it wired here is we are using the Cliff Quick Test like we always use. Now, since I have gotten this question several times before, hey, can I wire up the smart switch as the second switch? Now, there's many different three-way wiring configurations. I've tested it in the various ones I've seen in homes that I've been in. The power will come in, then go to a switch, then go to another three-way switch, and then it'll go to the light fixture. Now, there are other configurations. We'll leave a link to various configurations you may find to help you wire up a three-way switch in your home. But typically you could just swap out one of the switches and just match up the wiring with the travelers and everything, and it should work. In this configuration, we do have the Martin Jerry switch as the second switch. So the power comes in, goes to the dumb switch, goes to the Martin Jerry switch, and then to our light. So once you power it up, you will notice it will turn the light on and off once or twice. And that's the cool part of the switch. It's figuring out which way is on or off based on the three-way. That takes care of the rules that we've seen before, and you won't get things backwards because the switch does it itself. True smart three-way switch. So go ahead and power it up. And if you saw real quick, you'd notice that the light did flicker on real quick if you saw the glare from it, and it determined which way was on or off. So if we look at the console, you can see that the light is off, and we don't have any rules in here. So we'll simply toggle it on, it toggles on, we'll toggle it right back off. Real simple switch. It's set up pretty much just like, say, a Sonoff Basic, and it works right out of the box, no rules, very cool. Now, one thing you do need to change based on the template, because we like to do a long press option. If you go to the console, make sure you type in switch mode 1 5, and that's going to allow you to do that long press option from the switch. If you don't change the switch mode and it's default to the switch mode 0, the light will only be on as you're holding the button down. You definitely don't want that. Now you can go to the template and just change it to a button if you're not going to use a long press option, but I like to use the switch for the instantaneous pushes too. So to test out the 3-way capability, we'll go ahead and just push the button. Light comes on. Now, typically, if you're familiar with Tasmota, the console can be delayed a little bit. That's actually not going to be a delay from Home Assistant itself seeing the status. You can see, just turn off the 3-way switch. This is the dumb 3-way switch. And it shows right on the console that the on comes on. And then I can turn it off and it goes right to off. So your typical 3-way, and I do have this set up actually in my home right now in my living room on a ceiling fan. It's been working great. Now the one cool part I do like about the switch is you can go set up the LED colors. And since I have mine mounted next to 2 Martin Jerry dimmer switches, and those you can only have them set where the blue, because the way it is hardware configured, the blue is on when the light is on, and I have them set where the red comes on whenever the light is off. So I want this one to match as well. So the way to do that is we have a rule set because we're using a somewhat new feature with 6.60. If you look at configure template, you'll notice we use LED link. LED link is actually tied to a pin that isn't used, and that's just the way that currently Tasmota works with having to do 2 LEDs. You have to actually configure it for 3 LEDs. So we don't want the LED link configured or anything, but we have LED 1 and LED 2. That's the red and the blue. Well, now we can configure them actually as doing LED power commands instead of having to configure them as fake relays, which is pretty cool. So the way to do this, if you go to the console, and we're going to type in rule 1 on power 1 state equals 0, and that means when the power of the light switch goes off, we'll do a backlog, which a backlog is of multiple commands. We'll do LED power 1, which is to turn the first LED off, we set 0. Then we do LED power 2, 1, and that turns the second LED on, which is the red. And then we'll end that one rule. Now you guessed it, we'll do another rule which is just the opposite. So we'll type it again, or you can copy and paste it. And of course we will leave this in the video description. On power 1 state equals 1, do backlog LED power 1 to turn the first LED on, then semicolon for the second command, LED power 2 0 end on. So when the light turns on, it will do an LED power 1 of on, and then an LED power 2 of off to turn that LED off. We'll hit enter. Make sure and turn rule 1 on with a rule 1 space 1 command. You should see the rule 1 on. And now, when we go and turn the power on and off, we should see the different LEDs. So we'll toggle it once or twice. And now you'll notice when it turns off, you'll get just the red LED, and when you turn it on, you get the blue LED. Now, if you wanted it just the opposite, you would just change the rule and transpose things, so you would get the red LED when it's on and the blue when it's off. But of course, again, I wanted to make that match the Martin Jerry dimmers that I have right next to it. So that's all there is to it. Pretty cool Martin Jerry 3-way switch. Of course, it's just a switch, not a dimmer. But hey, at least this time around does have the ESP8266, unlike their dimmer didn't have that. Very surprising part was that we didn't need any rules with this switch. Definitely threw me for a loop because I was thinking going in I was going to have to do some rules and different voltage sensors like the other 3-way switches. But come to find out, we didn't need all that. It's a true 3-way smart switch. So I'll definitely have to say so far, it is now my favorite 3-way smart switch out of the various smart switches that I've tested that are 3-way configurable. So I appreciate you watching. Smash that subscribe button if you haven't already and hit that bell icon, and y'all take care.